So far, we've looked at finding the areas of triangles, parallelograms, and trapezoids. And today we're going to move forward and take a closer look at kites and figures that share properties with kites. So your new formula for the area of a kite is diagonal 1 times diagonal 2 divided by 2. You need to remember a few properties about kites. First of all, the diagonals are perpendicular to one another. And the diagonal that divides the pairs of congruent sides is bisected. So this segment is congruent to this segment. Those will be important facts to know. Also remember that a rhombus has characteristics of a kite and a parallelogram. So using our new formula, we can also find the area of a rhombus. And we can use it to find the area of a square as well. For our parallelograms, we still have area equals base times height, which means that our new formula is just an additional way that we can use to solve for the area. Looking at our first example, we've got the diagonals that are perpendicular to one another. We can fill in some information. We know that this portion of the first diagonal is 8. We've got the side of 17 and the side of 10. We now need to go and solve for our second diagonal, which is not divided into congruent pieces. So first I'm going to take a look at this right triangle here. This first right triangle has side lengths of blank 8, 10. And you can divide by 2, which gives you a blank 4, 5. And you're probably saying it's a special triangle. I know it's a 3. Don't forget to unreduce. Your unknown side was a 6. So this is a 6, 8, 10 for the first part of your diagonal. We then need to take a look at the second portion of our diagonal. So looking now at this right triangle, it is also a special right triangle. It is an 18. Our next example is also a rhombus. However, we're given a different set of information. They tell us that one of the angles is 45 degrees, and they tell us the total perimeter is 32 units. Knowing what we know about rhombi, all of the sides of a rhombus are congruent to one another. So if the perimeter is 32, then one side would be 32 divided by 4, or a total length of 8. So each of our sides are 8 units. We can approach this problem in two different ways. We can either use our brand new formula, diagonal 1 times diagonal 2 divided by 2, by applying trigonometry, or we can use our former formula, which is area equals base times height, and use what we know about special triangles to solve for the height. I would prefer to use the area equals base times height and work smarter instead of harder. So taking a look at my diagram, I've already drawn in my altitude or my height, so you can go ahead and do so as well. We know a lot of information about special right triangles. The first piece of information that I can fill in is across from my two 45-degree angles, I've got x and x. Across from my 90-degree angle is my x root 2. So 8 is equal to x root 2. Go ahead and hit pause and solve for your height, please. Come back and join me once you've done so. Divide by root 2. X equals 8 over root 2. I now need to rationalize by multiplying the numerator and the denominator by root 2. So 8 root 2 divided by 2, or 4 root 2. That means my height here is 4 root 2. Now applying my formula, I've got area equals 8 times 4 root 2, or 32 root 2 units squared. So sometimes you need to kind of weigh which formula is going to work best based on your given information. Looking at example 3, I would like you to fill in everything that you know and attempt this problem. So go ahead and hit pause. Come back and join me once you have given it your best effort. We've got a 30, 60, 90 triangle. And I can fill in that this side length is 8 and this is 5. And looking at my 30, 60, 90, I can solve for some portions of my special triangle. I know this length is x across from the 30. I know across from the 60 is my x root 3. And I know across from the 90 is my 2x. So if I solve for x, I get x is 4, meaning this portion of the diagonal is 4. And because my diagonal is bisected here, I know this length is also 4. And I know this length here is 4 root 3. Now be very careful because the 4 root 3 only goes for this portion of your second diagonal. So we still need to go and solve for our first portion of that diagonal. So looking now at this right triangle, you have a special triangle again, a blank 4, 5. So in this case, a 3, 4, 5. To apply our formula, we've got area equals diagonal 1 times diagonal 2 divided by 2. Our first diagonal is a total of 4 plus 4, which gave us 8. Our second diagonal is 3 plus 4 root 3, which you cannot actually add 3 and 4 root 3 since they are not like terms. So when I fill in my formula, I've got 8 times, I'm going to use parentheses for my second diagonal, 3 plus 4 root 3, all divided by 2. When you are simplifying, the reason I use parentheses is so that you will remember to distribute the 8 to both pieces of the second diagonal. So our area is 24 plus 32 root 3 all over 2. You now can reduce, and because both portions on either side of the equal sign reduce by 2, you can reduce all 3 pieces at the same time. So that gives you a total area of 12 plus 16 root 3 units squared. Make sure that as you are practicing each of these sections, you are working to recall all of your options for formulas and not just the current one that you are working on.